can you share with us your journey into the world of Sanskrit studies? What initially drew you into this ancient language and its literature?
Well, initially, I had been introduced to Sanskrit when I learned the practice of transcendental meditation. When I was 15 years old. And so I always had then a curiosity about where that tradition of transcendental meditation came from, because it had been taught by Maharishi Yogi, who was a student of the Shankaracharya of the North, Swami Brahmananda Saraswati. And there's a puja recited when we're taught, so that puja is recited in Sanskrit. So that was my first introduction to it. And then I got interested in reading the Upanishads. And when I was in college, I was interested in studying ancient language. I started studying ancient Greek and the philosophy of the ancient Greeks. That was my major in college. But there wasn't the opportunity to learn Sanskrit at that time. And I only started studying Sanskrit after college in graduate school at Brown University, when I thought that I would study the classics, and I had to take an intensive course in Latin in New York City to catch up on Latin. And when I was taking that course, I decided I really was not interested in reading Latin poetry. I was more interested in the philosophy. And so when I went up to Brown to join the classics program there, I asked the department chair, can I substitute Sanskrit for Latin and do Greek and Sanskrit? And he said, no, because we need to train you for jobs, and if you get a PhD from a classics department, then they expect you to be able to teach Latin and Greek. And I said, well, I don't have time. And so I didn't want to wait 3 years of going through the regular classics Latin and Greek program before I could start studying Sanskrit. So I just took up Sanskrit and then applied to the University of Pennsylvania, where I could study just Sanskrit.
Amazing, thank you. And how did you bring the computational aspect into the Sanskrit language? Like, what was the beginning of that journey? And can you just talk a bit about computational linguistics in Sanskrit, why this subject has developed so beautifully?
So while I was in college, a friend of mine had advised me that you're not going to get a job if you major in philosophy, and you'd better learn some computer science. So I took some summer courses in computer science, and afterwards started working for that friend's company for a few months. And then I had a job in Stamford, Connecticut with a company there as a computer consultant. So I worked for a year there before I went up to Brown. And when I was at Brown, I had a part-time job, 2 part-time jobs actually, one for the chair of the classics department and one for a linguist, where I started learning linguistic applications of computing. So when I was in college, when I was in graduate school rather, I put all of that aside while I was studying Sanskrit. But afterwards, Professor Cardona had a project to create a database of Sanskrit grammatical texts. And this included the Ashtadhyayi, the Siddhanta, the Ashtadhyayi, the Kashika, and the Mahabhashya. And I was responsible for analyzing the Ashtadhyayi and creating a database. And in the process of that, I wrote a program to do Sandhi, to implement Sandhi according to Paninian rules, including all of the options. And we used that to recreate the original from our Sandhi analyzed source. So that was the beginning of my combination of Sanskrit and computational methods. And then while I was at Brown, I was paid a visit by Gérard Douet, whom you know, who is also a participant in this conference. And he was interested in in the work that I was doing, particularly on the Ramopakyana. And so I had completely a detailed formalization of the Ramopakyana and analysis of it on many different levels, which is published in my Ramopakyana reader. And I just made a second edition of that now. And I had a web application at that time that presented the analysis in several steps. So one could look at the verse, then one could choose to see it in romanization. One could look at the analyzed Sandhi. One could look at notes that I had written on it, prose sentences that I had written, and English translation. And one could show or hide these things, and then also click on any word to get its morphological analysis and lexical connection, and then click on the lexical connection to connect it to a dictionary. And I had worked with somebody who was then a graduate student in the classics department and very experienced with the contemporary digital humanities world. He had worked with the Perseus project. And so together we were working to create a Perseus for Sanskrit, and that's what started the Sanskrit Library, which you see behind me on the virtual image here. So in 2002, I founded the Sanskrit Library, and we created a project with the Titus project, which then had the largest collection of Sanskrit texts as part of their Indo-European collection. And there were some 81 texts. And so we took their texts together with the digital version of the dictionary of Monier-Williams that was created by Thomas Moulton at the University of Cologne. And we wrote software in 2 steps. I wrote an XML representation of the Paninian rules to decline and conjugate nouns and nominals and verbs, so that we could create what we called a full form lexicon of all of the grammatical forms of all of the nominals and verbal forms. And we used the Monier-Williams dictionary as the base for that, and conjugated and declined all of the forms in that dictionary to create a way of mapping the declined forms to the dictionary. And we then reversed that automatic declension and conjugation software to create a morphological analyzer. And so Gerard Huet was then visiting MIT and Harvard, and he visited Michael Witzel at Harvard, and then he came down to Brown to visit me and invited me to the seminar he was holding in Paris, which turned out to be the first Sanskrit computational linguistics symposium. So at that event, which was not then called that, he, Amba Kulkarni, and I founded the Sanskrit Computational Linguistics Consortium. And then I had funding at that time in the project I just described. So I held the second symposium a year later, and Amba Kulkarni held the third, and we published the papers in the Springer natural language computation series. So that started the Sanskrit Computational Linguistics Symposium.
Wonderful. And you touched upon Panini. I know it's something you've worked a lot with. I believe also you were a student of George Cardona. I think
that's right.
One of the greatest Western Paninian scholars, if not the greatest. And how, because often it's paralleled with computation. Panini, the thought processes, the iterative approach and the functional approach of the grammar, of the sort of derivations. Can you just speak briefly about that, and also what projects that's inspired you to do based on Panini? It's a bit of an enigma for Western scholars because it's usually learnt, as a specialized subject, but I know that you've gone very deeply into it. I'd love you to just chat about that.
Yeah, so Paninian grammar is a derivational morphology. It's a process of derivational morphology, but it takes into account the semantics at first, and the syntax also to some extent. And so it creates the word forms on the basis of semantic and syntactic conditions. And this approach actually inspired Chomsky to create his analysis of the English language using a cascade of rules to account for forms. Prior to that, in the West, structuralism had analyzed language into units, strictly looking at contiguous morphemes, and to account for something more complicated, like what's called non-contiguous morphology, where you have elements that are related to each other but either overlapping or separated. It requires a different approach, and the original contribution of Chomsky was a transformational grammar, which took one kind of speech form as fundamental and transformed it into another, taking an active sentence, for example, as fundamental and transforming it into a passive. The approach of Panini is different, and that later X-bar grammar came to look more deeply at a more Paninian approach. Okay, but the Paninian approach is to start with the semantics, to go fundamentally to the deepest level of language, which is not the expressed speech form. The grammatical tradition in India recognizes 4 levels of speech. The Shabda Brahman, the absolute pure consciousness, and what's called Pashyanti, kind of insight, where you have a single gestalt of an idea, and it's not expressed in any kind of linear form. And then the Madhyama Vak, the middle level of speech, which is our discursive thought. And at that stage, one has speech forms in mind, and one has a sequence of speech forms, but one cognizes those speech forms as whole units. Then the most expressed level of speech is Vaikari, where you just have acoustic sounds, one following the other, and there is no actual connection between the acoustic value of the language and the cognition of the units of the speech, which is a mental phenomenon. So Paninian grammar takes the approach of opposite to what the Western grammarians do. The Western grammarians, after structuralism, there was descriptive grammar, where you're looking at the language first. You're looking at the expressed form of speech, and you're trying to understand it. So you're breaking it up into pieces and trying to figure out the relationships and so forth. So you're starting from the phonetic value, and you're trying to dive deeper into the understanding level, into the meaning level. But because of the pressure of the sort of materialistic science and empiricism in the early 20th century and middle 20th century, it was very difficult for the linguists to take a pure Paninian approach, because they don't want to recognize that there is anything mental, right? It's only the sense data that are considered real and criterion for scientific study. So the American descriptive linguists were working with just describing the phenomenon as they are. And Chomsky started to take a dive inward, looking at the grammatical structures as real entities, as real structures of our mental functioning, a faculty of knowledge. But the Paninian approach doesn't start from the outside and go inward. It starts from the inside and goes outward. So it starts from the meanings, the semantics, and then it introduces speech forms on the basis of those semantic and syntactic conditions, and then co-occurrence conditions, and then introduces the speech units, and then polishes the relationship between the phonetic representations of those speech forms, between the morphemes, to create the words as they're actually used and actually appear in the language. So that approach, actually, I undertook a project to, after doing that project with the Sandhi, implementing Sandhi rules and implementing nominal and verbal inflection. To create that, I hunted through the grammar and picked out rules for the various purposes I needed them. And there were, many mistakes and many refinements that were needed. And at one point I said, I don't want to hunt through the grammar to justify the results anymore. I'm going to start with the grammar as it's given and formalize the entire thing. And so I undertook a project with the help of Anuja and Tanuja Ajotikar, who are also Vyakaranis. They're experts in grammar. And we formalized the entire Ashtadhyayi in an XML formalization. And we are working on creating a computational implementation of that. It's a time-consuming task. We've done little pieces of it. I've done some demonstration derivations, which are on our website at the Sanskrit Library under derivations. Someone can look there. And it's very interesting to see how many steps are left out in explanations such as in the Siddhanta Kaumudi or Bala Manorama, which tries to give a more or less complete derivation. But those derivations are actually wildly incomplete. They're leaving out many steps, and they don't start from the beginning. Okay, so the beginning is just semantic conditions. What is the meaning we want to represent? And we start from there and categorize the meanings into the karakas and so forth, and then use those to introduce the speech forms and proceed. So we worked out how to do it, but I haven't implemented it computationally yet. Well, I haven't had time, but I hope to get to it within a few months, actually.
And on that note, could you talk about the past, current, and future projects of the Sanskrit Library, and some of the things you're planning to release and to achieve?
Yeah, so we extended the dictionary project. I wrote a grant proposals for the German Research Foundation and the National Endowment for the Humanities to expand our dictionary holdings. So together, Cologne and the Sanskrit Library expanded our dictionary holdings to about 45 dictionaries, which are now all available. Many people have downloaded them and copied them, and unfortunately don't give adequate credit to where they got them. But it was Thomas Moulton and I who created those dictionaries with a lot of help from volunteer help, I might mention, from Jim Funderburg. That was one of our most important projects. And then the others were to catalog the Sanskrit manuscripts and align them with manuscript images. So I had a project at Brown University and the University of Pennsylvania with a selected set of manuscripts on the Mahabharata. and then a project to catalog the entire collection at Harvard University. So we cataloged about 2,000 manuscripts there, and we have a digital catalog of those manuscripts. Let's say the first edition of that catalog has been online already for several years. And in the next few months, actually, I'm working to finalize that and also make a print version of it. So future projects involve completing the computational implementation of the Panini grammar, and then using creating a dictionary from the forms created. Because if we create all the forms from semantics and have that whole rule history, we can reverse that to show the meaning and the derivational history of every form, which itself is a dictionary, a purely Paninian dictionary. And we'll use that as a basis to integrate all of the dictionaries. And once we integrate all of the dictionaries, then what we hope to do is use that as the basis of a search engine to analyze texts, because we'll have the relationship between the forms as they appear in text, even sandhi'd, and use that to find the matching forms and connect them with that dictionary. So that will create a way of connecting texts with the linguistic analysis and the dictionaries to allow what people have been trying to do for Sanskrit for a long time now, in partial ways, to make a really useful online library of Sanskrit.
Do you think the large language models and the current acceleration happening with neural networks and machine cognition can accelerate these goals?
Down the line, they can, but at present, they can't, because we just don't have enough data. We don't have enough data that aligns Sanskrit text with its analysis and interpretation. There have been some people who have been creating a lot of that data, particularly I'm sorry, his name is
Oliver Helbig.
Oliver Helbig.
Yeah.
He's done a fantastic job of creating a lot of data. And we had projects in conjunction with Gerard Huet to try to create some of that data. We did create some, but it's not a significant amount. It's not nearly enough to be useful for artificial intelligence methods. But we hope to get there. We'll get there. I've experienced people working on projects to try to use contemporary computational methods to analyze Sanskrit. And I saw such a project at Brown University, someone in the computer science department. And the professor who was advisor said, well, he did a great job on the computational side. But if you looked at the results that it achieved for Sanskrit, it was just total garbage. Right. So that has formed my impressions most firmly that we're just not ready. We need more data. He didn't have the right data to work on. So
it's 9:30 here. Do you have time for another question, or do you have to dash for the class?
Let's make it one brief question, then I've got a class starting.
Actually, in 2015, I met you in Bangkok, and you spoke about the magnitude of Sanskrit literature and this incredible corpus of manuscripts, some extant, some not. Some existing still in manuscript form. What are the
not
attempts?
Edited, not yet critically edited.
Yeah, not edited. Yeah, what's happening? I mean, firstly, could you comment on the magnitude of Sanskrit in comparison to other languages? Pre-printing press, of course.
Sanskrit has been the language of learning, of scholarly exchange in India for at least 3.5 millennia. which is a huge expanse of time, uninterrupted. And this is unmatched anywhere in the world. We've got other languages that have had the role of being a sort of lingua franca, as it's called, named after when French was such a language in the 17th century, and English is becoming that language now, where all of the scientific work, all of the literary work, research, if one wants it to have the widest readership, has to be in that language. Well, Sanskrit was that language in South Asia. It spread over Southeast Asia, and with Buddhism into China and Japan, Korea, throughout Southeast Asia and Sri Lanka. And so its breadth and scope was enormous and uninterrupted. So the so-called Dark Ages in Europe limited the quality of research for centuries, where such a period never happened in India. And while Prakrit evolved from earlier Sanskrit and then broke up into regional languages, Prakrit was a lingua franca for a short period of time in the Ashokan Empire. But as time went on, the regional languages diversified, and it lost its lingua franca status. But Sanskrit was then turned to again as the language common to all areas of Sanskrit for scientific expression. So there's an enormous body of work in Sanskrit, and I would say it's the largest body of literature in the world prior to the invention of the printing press. There were estimated to be by David Pingree, who was an avid book collector and manuscript collector, and worked exhaustively on the Jyotish Shastra, manuscripts of mathematics and astronomy and astrology, and created the census of the exact sciences in Sanskrit in 5 volumes, the 6th of which still has to be published. He estimated that the extent of Sanskrit manuscripts was in the order of about 30 million. The National Mission for Manuscripts in India since then began its census of the manuscripts held by all the manuscript libraries in India. They've already enumerated about 12 million. So it's probably not far off from what Pingree's estimate was. If we can save those manuscripts before they become extinct, before overly enthusiastic religious people throw them in the Ganges as offerings, or when the descendants of some Sanskrit scholar who are not Sanskritists find some paper on a shelf and start using it for fuel or wrapping vegetables in, then those manuscripts are destroyed. So there's a race against time to digitize all those manuscripts, and then there's another project which I've discussed with you previously, the project undertaken in Madras, in Chennai.
New Catalogus
Most recently, the new Catalogorium, most recently under the editorship of Siniruddha Das, and it published created some 42 volumes of a catalog of catalogs. That is a listing of all the manuscripts in all of the catalogs of India and elsewhere in the world. Although its scope may not have included all of the catalogs, but it's the greatest detailing of the works and authors of Sanskrit literature that's ever been done. And it's extremely important to give people an accurate idea of what literature there is in Sanskrit. It's a knowledge map of of the production of literature over those 3.5 millennia. And to utilize that to its full extent is also an extremely important project. And I know I've talked with you about that before, and you've undertaken quite a bit of work in that direction yourself.
Thank you so much,
so we hope
Professor
that we hope that gets completed, and that we can use that knowledge map to connect with all of the original catalogs that it catalogs, and use those catalogs then to extend an integration of the manuscripts and published works and editions of those works to make a knowledge map that extends all the way down to the individual text. And that, of course, is an enormous project that will take decades to achieve.
Thank you so much, Professor.
And these are
Scharf.
these are the projects that involve digital humanities work. And it is my hope that the Sanskrit Computational Linguistics Symposia will pay attention to these kinds of projects, and not just focus on copying the kind of work which is being done for English and modern Western languages, attention to artificial intelligence and so forth, which right now are just gimmicks that don't really help us with these projects in the Sanskrit world. But this is why we created the Sanskrit Computational Linguistics Symposium. It's for doing computational work on the enormous body of Sanskrit literature. And the Sanskrit Library has started offering a program in digital humanities that will train more students. We had hoped of a workshop there to involve some more students, and maybe we can do that in the future. That will train more young Sanskrit scholars in digital methods. Yeah, we'll talk about that.
We'll talk about that. Thank you so much for the magnificent interview.